Ever wonder how machines can spot a tiny crack in a car part or a speck of dust on a smartphone screen without ever being told exactly what to look for? That's the magic of anomaly detection. And today we're diving into a game-changing AI called NexViTAD that's making this possible. Let's break it down. Imagine you're a quality control inspector in a factory. Every day, thousands of products roll off the line, and you need to catch even the tiniest flaw. But here's the problem. Defects are rare, expensive to label, and look different in every factory. Traditional AI systems rely on huge piles of labeled data, like thousands of photos of broken parts, but that's not always feasible. That's where NexViTAD steps in, like a super smart assistant that adapts to new environments without needing constant hand-holding. So how does NexViTAD work? Let's start with the basics. It uses vision foundation models. Think of them as AI's general knowledge base. These models, like DINOv2 and Hiera, have already learned to recognize patterns from massive amounts of unlabeled data. DINOv2 is great at understanding the big picture, like knowing a tile is a tile, while Hiera zooms in on the tiny details like cracks or textures. But how do you combine these two? NexViTAD fuses their strengths, creating a hybrid that sees both the forest and the trees. It's like giving a detective a magnifying glass and a satellite map. But here's the real trick: cross-domain adaptation. Imagine training an AI in one factory with bright lights, then sending it to another with shadows and different sensors. Traditional models struggle, but NexViTAD aligns the language of features from both environments into a shared space. Think of it as teaching a bilingual person to switch between languages seamlessly, so the AI can spot defects no matter where it's deployed. Now let's talk about how it finds those defects. NexViTAD uses a technique called Sinkhorn-K-means clustering. Picture a memory bank storing normal samples, like a security system learning the faces of regular customers. When a new image arrives, the AI compares it to this crowd, grouping similar patterns and flagging outliers. It's like a bouncer at a club who knows the regulars and instantly spots an intruder. The results? NexViTAD crushed the competition. On the MVTec AD dataset, it achieved a 97.5% AUC score, nearly perfect, while also pinpointing defects at the pixel level. It's not just fast, it's precise, handling everything from frayed cables to smooth leather with ease. And here's the kicker: it does all this without needing labeled data from the new environment. That's a huge deal for industries where labeling defects is time-consuming and costly. So why does this matter? Think of it this way: NexViTAD isn't just detecting anomalies, it's redefining how AI adapts to real-world chaos. Traditional systems require exhaustive training for every new scenario, but NexViTAD learns to generalize, much like a human inspector who can spot a flaw in a new setting without being told exactly what to look for. This is the future of AI in manufacturing, healthcare, and beyond. Systems that don't just follow rules but understand contexts. Ever wonder how AI can get better at solving problems without being told exactly what to do? Let's talk about a game changer in machine learning: multitask learning. Imagine a chef not just learning to cook a single dish, but mastering everything from chopping veggies to cleaning up, all at the same time. That's what researchers are doing with AI models. They're teaching them to tackle multiple challenges simultaneously. Take papers like RealNet and XDNet, which show how this approach helps models adapt faster, especially when there's not much data to work with. Why does that matter? Well, in the real world, getting labeled examples like perfectly annotated images is tough. Multitask learning is like giving the model a superpower to learn from less. Now let's look at how this works in practice. Researchers tested these ideas on the MVTec AD dataset, a gold standard for spotting tiny flaws in surfaces. Think cracks in metal sheets or defects in textiles. The results? Pretty cool. In one experiment, a model not only spotted a crack, but also highlighted exactly where it was with a heat map. But the real magic happened when they mixed techniques. Here's the kicker: hybrid approaches beat single-method solutions. By combining old-school reconstruction tricks with cutting-edge tools like denoising diffusion models, think of them as AI cleaners that remove noise from data, researchers achieved better accuracy. It's like giving a chef a recipe book and a sous chef. Teamwork makes the dream work. So what's the takeaway? The future of AI isn't just about doing one thing well. It's about learning to juggle, adapt, and solve problems in smarter, more flexible ways. NexViTAD and multitask learning aren't just technical advances. They're blueprints for building systems that thrive in uncertainty. And that's why this research isn't just sci-fi. It's shaping the tools we'll use tomorrow. Thanks for watching. If you want to dive deeper into the math behind Sinkhorn-K-means or explore how diffusion models work, hit the links below. Stay curious, and we'll see you next time.